In this video, we will create the third window which will render the camera's output. Let's get started. We need to create a new file called detection_window.py. Within this file, we need to define the class named detection_window. Before we proceed with the class definition, we need to import the required libraries. Once libraries are imported, we need to define the init constructor. This constructor will be called once the class object is created. We will create the class object from the settings window class. Before we do that, we need to inherit from Q main window class, load the UI file, and map the button. The super refers to the Q main window class. By writing super, we define that the detection window class is a child of the Q main window class and inherits its functions. Now we can load the UI file. The path needs to refer to the detection window.ui location. To map the button, we need to type Here we are mapping the stop detection button, which we can find within the detection window.ui file. Right here to the close method. When the button is pressed, the close method will be called. We do not need to define the close method as our class inherits it from the Q main window class. Before defining this class methods, we need to create another class called detection. Create a new file called detection.py and define the class within it. The detection class will inherit from the QThread class and will be responsible for running the detection algorithm. The QThread class will allow us to run the detection within a separate thread. By running the algorithm on a different thread, we will be able to keep our UI responsive. Now we can import the required libraries. Also, let's define the class constructor. Within the constructor, we only need to define the super, as the detection class is only responsible for running the detection algorithm. Once done, we can return to our detection window class. Also, let's not forget to save our changes. Now we can import the detection class that we have just created. Once done, let's define the detection window class methods. Here, we create and assign the detection class object to the detection variable. Now, we need a method that will map the camera's output to our UI. Here we are using PyQtSlot decorator. Decorators allow us to add functionality to our methods without modifying its structure. The PyQtSlot decorator will let us to map the camera's output to the label called label detection. The setPixMap function will load the image in our instance the camera's frame to the label. The QPixMap from image function will handle the camera's frame. It will receive the emitted frame from the detection class. Now, let's define a method for starting the detection. In this method, we need to connect the detection class variable to setImage method to be able to receive the camera's frames. Then we need to start the detection thread and show the detection window. Finally, let's define what will happen when we will close the detection window. When we will close the window, we need to stop the detection algorithm. We are using close event. This event is triggered when the application is closing. We are stopping the detection thread before we continue with the event. Now we need to write the camera's output logic within our detection class. Let's begin by defining the changePixMap variable that we are using to receive the camera's frames within our detection window class. After that, we need to define the run method. This method will have a while loop where our detection logic will run. Let's define a variable that will control our loop. Also, we need to assign the camera's capture to a variable. To do it, we will use video capture function. The number here represents the system's camera. I am using 1 as it works with my system. If you will have any issues with the camera's output, try changing this number. Now we can define the while loop. Within this loop, we need to read from the camera and save the output to 2 variables. The first variable will hold a Boolean value. If the function is able to read the camera, it will return true. The frame variable will hold a captured frame. Let's define the logic if the video frame is read correctly. Then we need the height, width, and channels of the frame. We can get them from frame.shape. Also, we need to convert the color channel from blue, green, red to red, green, blue, RGB. As by default, blue and red channels are switched. Then we need to calculate how many bytes per line the frame takes. After that, we can convert the CV2 image to Qt format with this function. Then we need to scale the converted image in order for it to fit within our UI. As I have tested, these values fit our UI best. The third parameter tells the function to keep the aspect ratio of the frame. Finally, we need to put our converted frame to the UI. We are doing it by emitting the frame through the change pixmag variable that is linked to our UI. Save the changes by pressing Ctrl S. Now we need to edit the settings window class. At first, we need to import the detection window. After that, let's remove the print statement and let's type. Here we check if the detection window is visible. If it is, we print detection window is already open to the console. If not, we call create detection instance and start detection methods. Also, we need to define what will happen when the window is closed. Within the close event method, we are checking if the detection window is visible. If it is, we set the running variable to false, we close the window, and we continue with the close event. Let's save the changes and let's test the application. I have already opened the client-side folder within the terminal. Let's type python main.py. It seems that we got an error. We forgot to reference the detection window class. To fix it, we need to edit the settings window class. Here we are initializing the detection window class. Also, I have noticed that there is a typo within this function. It should be color_bgr2rgb. Save the changes and let's test the application once again. Everything is working as expected. Here you can see my hand. In this video, we have created the detection window, which is capable to read the camera's output and display it within our UI. In the next video, we are going to train our detection algorithm. See you in the next video.